Hello, I'm Laura Marshall.
And I'm Melinda Rose, and this is Light Matters for September 18th, 2013.
On today's show, a European group is working on taking the fry out of skyscrapers, sculpted light captures brain activity, and a bioimaging laser branches out to bomb detection.
Our first story this week is a real scorcher. A pan-European consortium aims to give city planners key environmental analytic tools, which they say could prevent the rise of another skyscraper. The most recent example is the Walkie-Talkie, a $378 million 37-story tower under construction in London's financial district that's scheduled to be completed in March. Its curved surface concentrates and reflects sunlight hot enough to melt car parts, blister paint, and literally fry an egg on a sidewalk, according to media reports. The light it projects onto the streets below is so intense, some have renamed it the Walkie-Scorchy. Parking spaces nearby were closed after several car owners complained that the ultra-bright light melted parts of their vehicles. A two-story scaffold was also erected to absorb the rays. The developers are evaluating longer-term solutions. The building's architect, Raphael Vignoli, told the Guardian newspaper that he and his team did predict a glare problem, but didn't realize the extent. They predicted the temperature would be about 36 degrees higher, but it turned out to be more like 72 degrees. Vignoli is also famous, or infamous, for designing the Vdara Hotel in Las Vegas, which also served as a gigantic light concentrator when it opened in 2009. Vignoli insists that it was a very different problem and that he was following a master plan specifying arc-shaped towers. He told The Guardian that they pointed out the issue then too, but, quote, "Who cares if you fry somebody in Las Vegas, right?" End quote. The KIC Transitions Project, a consortium led by Birmingham City University, says the predicament highlights the need for city planners to use a more integrated approach that lets them plug in a wide range of data sets for analysis of key environmental impacts, including energy needs, noise pollution, or carbon emissions.
And even unintended death rays.
Yes, that too.
A new high-speed imaging technique sculpts the 3D distribution of light in a sample enough to resolve a single neuron in a living C. elegans worm. A major aim of neuroscience today is to understand how the nervous system processes sensory input and generates behavior by observing the activity of cells across the entire brain. But scientists need detailed maps of how the nerve cells are wired in the brain, plus information on how these networks interact in real time. Until now, researchers have focused on studying the activity of single neurons and small networks in the worm, but haven't been able to establish a functional map of the entire nervous system. The trade-off has been between spatial or temporal accuracy. Previous approaches scanned focused light in all three dimensions, but it takes so long that recording all neurons' activity at once is impossible. Now, researchers at the University of Vienna have found a way to generate disks of light in a sample. That means they only have to scan in one dimension to produce 3D videos showing the activity of many neurons simultaneously and how they change over time. But there were other challenges too. Visualizing the neurons requires tagging them with a fluorescent protein, but the worm's neurons are so densely packed that they couldn't distinguish them on initial images. So they tagged the nuclei rather than the whole cells, thereby sharpening the image to identify single neurons. They found they could record 70% of the neuron's activity with high spatial and temporal resolution. The team hopes to refine the method to apply to freely moving animals in the next 2 years. The work appears in Nature Methods.
A laser-based imaging method originally developed to detect cancer is now putting the possibility of bomb-detecting lasers at security checkpoints within reach. Michigan State University chemistry professor Marcos Dantas has developed a laser that senses microtraces of explosive chemicals on clothes and luggage and provides an image of the chemical's exact location, even just a tiny trace on a zipper. Scientists have worked for decades to develop lasers strong enough for detection but safe enough to use on people. Dantas's initial spark came from collaborating with Harvard on a tool that could detect cancer but only has the output of a laser pointer. As they worked on biomedical imaging, Dantas looked at other uses and found that the laser could detect traces of hazardous substances from up to 10 meters away. It works as a single beam but uses two pulses. The first resonates with chemical frequencies found in explosives. The second is a shadow pulse. Any discrepancy between the two indicates explosives. But airport security won't likely be armed with handheld lasers. This laser would be used like the X-ray scanners already in place for airport security. Dantas said a prototype could be created in about a year. The work appeared in Applied Physics Letters.
Well, that's it for this edition of Light Matters, the Photonics Industry's only weekly newscast.
Just a reminder that if you haven't yet entered the PRISM Awards for Photonics Innovation, the applications are still open.
You can apply until next Friday, September 27th.
And you can go to photonicsprismaward.com and the applications are there to download. Don't procrastinate, you only have about a week or two left.
And as always, if you want to communicate with us, you can write to us at lightmatters@photonics.com.
Thanks for watching, and we'll see you next week.